selamat datang kepada para peserta dari Indonesia. Kami dari Teknik Geosynthetic Asia Indonesia Trade Representative Office mengadakan webinar dengan tema khusus di aplikasi penambangan, di mana di sini kami ingin membagi beberapa pengalaman dan juga pengetahuan kami dalam menghadirkan beberapa solusi dalam aplikasi pertambangan, khususnya yang ingin kami bagi kepada teman-teman di Indonesia. Dikarenakan hari ini ada juga beberapa peserta yang datang dari luar negeri, dari India, Malaysia, Australia, dan Filipina, serta juga kemungkinan akan hadir dari teman-teman Amerika. Kemungkinan saya akan selalu memakai dua bahasa, sehingga saya pun akan mengucapkan selamat datang, welcome to our friend from other country outside Indonesia, to Indonesia Mining Geosynthetic webinar. So before we begin, for those of you who are just joining this webinar for the first time using Teams platform, if you experience a lack of resolution of your screen, you can change your resolution settings from your settings icon below. So you can find your settings icon on quality and you can change the resolution as you need it. Untuk teman-teman dari Indonesia yang mungkin mengalami sedikit buram ataupun resolusi yang kurang jernih, bisa mengganti setting quality-nya ada di icon setting di bawah, sehingga bisa mendapatkan presentasi yang cukup baik. Untuk hari ini dengan 3 topik, kita akan membagi beberapa waktu presentasi dari sesi pertama, sesi kedua, hingga sesi ketiga. Dengan sesi pertama akan dibawakan oleh Mr. Doyo dengan topik Introduction to Geosynthetics for Mining Application. Beberapa catatan yang ingin saya sampaikan dalam selama webinar ini, terutama untuk sesi pertama ini. Yang pertama, para peserta akan mute untuk mic-nya sehingga tidak bisa berbicara. Dan untuk sesi yang pertama ini tidak ada untuk sesi pertanyaannya. Namun bagi teman-teman yang ingin menanyakan lebih lanjut terkait teknik geosynthetic, khususnya untuk sharing knowledge di bidang pertambangan ini, bisa menghubungi kami melalui geo.indo@teknikgeo.com. Dan untuk video recording terhadap semua webinar ini akan tersedia untuk teman-teman yang sudah mendaftar dan bisa melihatnya. Namun untuk sesi pertama ini, materi presentasi mungkin juga tidak akan dibagikan. Serta untuk sertifikat partisipasi teman-teman akan diberikan kepada teman-teman yang hadir pada acara hari ini. So, to be noted too, if you are joining in this webinar without sign in into Teams account, please reply our reminder email that have been sent out to you to acknowledge that you are interested to get the certificate. And your email will be counted if you send it during this webinar. Bagi teman-teman yang join dengan webinar ini tapi tidak melalui account Teams, jangan khawatir, untuk mendapatkan sertifikat bisa menjawab email reminder yang sudah dikirimkan sebelumnya selama webinar ini berlangsung. Ya, tanpa berlama-lama lagi, saya ingin memperkenalkan terlebih dahulu pembicara pertama pada hari ini. Hari ini untuk topik yang pertama akan dibawakan oleh Mr. Doyo Lujung Diwarso. Beliau adalah Country Manager dari Teknik Geosynthetic Asia di Indonesia dengan pengalaman 12 tahun di bidang geosynthetic dan juga sudah memiliki banyak pengalaman dalam mendistribusikan seluruh brand Teknik di Indonesia. Pak Doyo sudah aktif dalam berbagai proyek, di mana tanpa bisa kita hitung kembali aplikasi-aplikasi geosynthetic yang sudah beliau aplikasikan dalam proyek-proyek Indonesia, meliputi dari beberapa bidang seperti transportasi, infrastruktur, hydraulic and marine, pertambangan juga ada, dan juga landfill di Indonesia. Tanpa memberi diri lebih lanjut, kita akan mulai sesi pada Oyong.
Thank you, Mr. Hadi. Ladies and gentlemen, good morning to participants from Indonesia, and good afternoon or even good evening to participants from the overseas. Firstly, on behalf of Teknik Geosynthetic Asia Indonesia Representative Office, I would like to thank you and appreciation to all participants for attending this event. My presentation this morning is about the topic Introduction to Geosynthetic for Mining Applications. My presentation consists of 3 parts. From the first part is a company introduction. The second part is geosynthetics for mining application, and the last one is some selective project reference. I will start with the company introduction. Teknik Geosynthetic is the global industry leader in geosynthetic with the following advantage. As the largest global manufacturer, leader in innovation, it funds application knowledge, technical and design expertise, experience and global track record, uncompromised quality, and the first-class distribution. Our vision is to be the leading global provider of geosynthetic products and solutions that enhance the world infrastructure, protect the environment, and conserve natural resources. Teknik has a global footprint and has worldwide network with the headquarters in Pendergrass, Georgia, US, and has network of production facilities and sales office in America, Europe, and Asia. And the production facility spread over all the world. We can see from the picture that our production is located in Europe, in US, and in Asia. In Europe, we have the production facility in Linz, Austria, Dijon in France, and Neverdal in the Netherlands. And for US, our production facility is in Jefferson, Georgia, Cornelia, and Commerce, all is in Georgia, US. And in Asia, we have the production facility in Shah Alam and Senawang in Malaysia, and Zhuhai in China. So we can say that we act as the global company, but the product is locally. With our location spread all over in the world, it's easier for us to deliver the material and easier also to understand the market every different area. We serve the main market, which consists of building site infrastructure, transportation infrastructure, local government infrastructure, mining and energy, water infrastructure, and environmental infrastructure. If I can say like one by one is the most important is like transportation infrastructure will cover for highway and roads, railways, airport runways, and bridge. And for this webinar, we are mostly talking in the mining. And we can see also from the other key market is for water infrastructure. This is mostly for dams, coastal protection, inland waterway protection, port and harbor, pond and canal. And the other market that's very important also, especially for Asia market, is for environmental infrastructure. It consists on the solid waste landfill. Like our country, the solid waste landfill, our country every year develop a lot of solid waste landfill. Our company implement international standard manufacturing control and assurance and certified according to ISO 9001-2015. And if you can see from the map that our distribution network in Asia is split from China in the north, Japan, Korea, and until New Zealand in the south. And from the west to the east is from India on the west until Philippines on the east. Geosynthetic testing laboratory is the key element for the manufacturer of geosynthetic, and Teknik Asia, our laboratory has been certified with comply to ISO 17025 accredited laboratory test facility, and this laboratory is the first specialized geosynthetic laboratory accredited in Asia. And our geosynthetic testing laboratory able to do testing with refer to three standard consist of ISO, ASTM, and GRI as the following table and relevant to civil environmental engineering works. The next slide shows certificate from JELAB as the geosynthetic testing laboratory, and also the certificate from the Department of Standard Malaysia. In Indonesia, our offices are split over to three parts of Indonesia, from the west to the east to cover all territory. In the west, we have a branch office in Pekanbaru that mainly to support Sumatra and west of Indonesia area. And the center we cover from Jakarta also as the main office in Indonesia. And in the east, we have the branch office in Makassar. So basically in Indonesia, we are able to support on the area and product technical sales, and also we are able also to support on the design engineering. Mr. Hadi is our design engineer in Indonesia, now to be a host. And for commercial matter, we are doing collaboration with the selective partners and distributors. Okay, now we are going to the brands of Teknik and detail of the product. Then the first brand is Teknik Polyfab. This is a very popular brand, especially in Indonesia and also for Asia market and also for in Europe, because originally this brand came from Austria, Europe. This is encompasses a wide range of non-woven and composite combined with non-woven element for various market infrastructure. And in Asia, we have the manufacturing facility to produce Teknik Polyfab consists of non-woven and composite in our production facility in Malaysia. And the next one is Teknik Mirafai. This is a high-performance woven geotextile, especially for soil reinforcement and heavy-duty application. And the next is Teknik Miragrid. This is the high-strength geogrid and has been used around the world for soil reinforcement application. The next is Teknik Geotube. This is for engineer containment system for water infrastructure and for environmental dewatering. Okay, so I'm going to show you one by one what kind of product under Polyfab and what kind of product under Geogrid. The Teknik Polyfab cover a wide range of non-woven geotextile and composite. So if you can see from the picture on the top left is for non-woven, divided into non-woven and heavy-duty non-woven. that we can supply from the lowest weight is like 120 grams, and we are able also to do now until 2000 grams per meter square. This is very good material. And the next one is PEC composite. This is very popular and very good material that good for soil reinforcement. And the next one is PGNG for paving reinforcement, Polyfab F for filtration, and Ali drain prefabricated vertical drain for ground improvement. And for the environmental application, the product is a geocell, infrared geocell, polymer erosion control mat, infrared made from coconut fiber, and the good material environment geosynthetic clay liner. This is now become the popular product for lining, included for pond lining and also for landfill. And the last one is DC drainage mat and composite. The next is for Tenkate Miralfai. This is for high strength woven geotextile. The PET high strength woven is made from high tenacity polystyrene. That is different with maybe the same PET other product. Our PET made from high tenacity polystyrene. And the next one is HPA woven. This is the very good and new development in Tenkate Asia, and the similar with the market for Australia and for US is under brand RSI woven. And the next one is PP woven. And the last one, FW woven. This is the filter width. So the filter made from woven geotextile. The next one is the geogrid also. Our geogrid is made from high tenacity polystyrene. That is different with even the same yarn, but we made our product is from high tenacity polystyrene. And the last one is Tenkate Geotube. It's cover for geobag, sand fill mattress for reverb protection, and also concrete mattress filled by concrete mortar. And Geotube Marine, very good product, and now split to all Indonesia and also to Asia market for marine application. And Geotube dewatering, that the next presenter, I think Pak Sang will mostly discuss about the Geotube dewatering. And the last one is the circuitan, this for pollutant control. Okay, now I'm going to the next part on the geosynthetic for mining application. My time is like too slow, so I start to make faster. So, what is the geosynthetic? Geosynthetic can be simply defined as geosynthetic material or polymer used for geoengineering application. So we can say like the key is about geotechnical, geohydraulic, geoenvironmental, and others. So the geosynthetic have the function from the spiration, protection, soil reinforcement, confinement, filtration, drainage, wicking, sealing, and erosion protection. The simple thing is we can see from the picture how it's work for each function. So I think another series of webinar already given detail of each function from spiration, reinforcement until erosion protection. So on the mining application also have relation with the function. In this webinar, the mining is our concern. So if we check one by one, is the function is from the embankment and slope. The function is for the basal reinforcement, reinforced slope erosion control. And the next one is for the dam walls and retaining structure, haul roads, port expansion, tiling and water management, closure and rehabilitation, railways, and mine processing. So in this slide, we just very short explain one by one, but I will pass from the item for closure rehabilitation and mining processing and tiling and water management, because this is part of the main discussion will be presented by next presenters. Okay, so I will start with embankment and slope. That mostly consists of three applications. This is for the reinforcement for the slope, and the second one is for reinforcement layer for the basal reinforcement, and the last one is for the surface erosion control. Okay, so if you can see the detail for the embankment and slope, This is high embankment in heavy load from mine infrastructure, and low head embankment over soil are very common mining challenge. So if you can see from the picture, the geosynthetic is placed in the bottom of the embankment. So the function is to be the vessel reinforcement. So Mirafi PET is very good material to this application, and our product now can meet up to 2000 kilonewton. The next one is application for slope. Yeah. The reinforced soil slope create access road or working platform and can utilize that one material as the fill and backfill material. Okay. So if you see from the picture that the geosynthetic is placed layer by layer as a slope reinforcement. So our product made for this application is geogrid and also PEC composite with good for fine material, backfill material, and also Mirafi PET that have the ring until a very high tensile strength. And for erosion control, we use one of them is for polymet geomet. The next is application for downwall and retaining structure. This one is very common application in the mining. That our product can meet this application is using geogrid and also the polyfed PEC composite. Okay, now we are going to the next application is for haul roads. This is the main application because in the mining have long roads for mining and also for haul road. That the function of this geosynthetic is have the following benefit. One is a cost saving and lower environmental impact. And the next one is for the separation, that no mixing between the granular material of the root construction and the subgrade. And the last one is to improve stronger platform over time due to the reinforcement. So the one is depend on the subgrade condition and the traffic load. The lightest one is we can use only aspiration. That we have the product qualified TS. The function is separator to prevent upper granular layer penetrating to the subgrade beneath. So if you can see from the picture, with using the geosynthetic, we can reduce the fill layer embankment. This one it will be cost saving when we use the polyfed TS non-woven. And if the ground is very soft and also the traffic is very high or very heavy, that the aspiration is not enough, and we need another geosynthetic that can be function aspiration and reinforcement. And if you can see that we saw the comparison between without using geosynthetic, we use separator only, we use the geogrid, and also we use the new product developed by Tenkate under brand Mirafi SP Geotextile. So if you see with using the Mirafi SP, the embankment can be minimized. This is cost saving for miners and very good material. Okay, I just show the comparison on the fourth main function of this product, and the brand is Mirafi SP as the reinforcement performance. We can see from the picture how comparison between SP and also with the geogrid. And the next one, the very good function is the confinement performance. The confinement is meaning to restrain the lateral movement of the soil. That HPA will have the friction and have the lower elongation. That one will be good for reinforcement. And also other side also have the permeability performance that we cannot find in the geogrid product. And of course also a separator performance. So this is for haul roads application. And next is to the pot application. That one is for hydraulic application, that we have the product under YouTube and under Mirafi FM series. So this pot is very main part of the mining supply chain, and this is to deliver material from the mining to the other area. So if you can see in the picture, in the Mirafi FM concrete matrix can be put as basal reinforcement, and the polyfat PS is to be filtration under riprap, and Q2 can be a core or breakwater, and also for the dun. Okay, railway, even we never find this one, but the next infrastructure for the mining railway should be very main part of the mining to deliver the mine product to the port. That the product we have is a Mirafi SPG, is the composite geotextile product with 2 layers of woven and non-woven, is a combination with high tensile modules and high cross field permeability for mechanical stimulation and small pore opening size for the ability. I think detail for the product, I think its participant interest can contact our office to see the detail of the SBC. This is specialized for railway application. And the next one is tiling and water management. I will pass this slide, and the next presenter should be explained on the tiling and water management. So included application is using GCL for the lining of the pond, and also the non-woven as protection against the lining system, is like for geomembrane. Okay, the next presenter will talk detail about the tiling water management using geotube dewatering, and also for mine polishing. So for the participant, please keep follow this webinar, because the next presenter will talk to detail on this 3 applications included for closure and rehabilitation. I will pass this one. Okay, so finally I'm going to the last part of presentation. I just saw some selected project reference, especially in Indonesia, and some of from the work that already was the okay. For the first thing is the application of non-woven composite reinforcement for separator for mine road. As I informed earlier, the Hal road is the very good application for the material. This is for the coal mining in South Kalimantan. It's already 10 years ago. Then the next one is the project for slope application. This is the name is the Ras Melawan. This is one of coal mining in Kalimantan. We can see here that PET 350 install layer by layer for slope reinforcement for the mining application. And the next one also still using PET, but the function is for basal reinforcement under stockpile. So this part of the PET can be used as a slope reinforcement, and also able to use the basal reinforcement. Okay. The next one is application of steel PET woven. That one is used for. Okay, sorry, just one slide before is application of geogrid GA200/50. This is for reinforced structure in the gold mining in East Indonesia. If you can see here, the slope head is 20.5 meter, and the geogrid installed layer by layer. Okay, the next one is PET 200/50. It's used for slope reinforcement. The slope head is variation up to 12 meter slope. And this is just installed last year in one of cobalt mining in the South Sulawesi. To just show you the rough drawing, so that layer by layer install using PET 200. So just inform to all participants that Teknik provide the technical support. We can give the proposal. It included the detail of how the material will be installed on the execution. So another interesting application is for dam site for coal gradation, mechanical screening in PT KPC in East Kalimantan. This is a long time ago, but this is very good application that we use the PEC as because the fill material contain a significant fine fraction, that PEC as reinforcement was chosen due to its better performance with residual soil. So I can inform the PEC is very good product for the field embankment with have the fine residual soil. So this application is for wall. The height is until 18.5 meter. You can see the drawing, the two type of PEC installed on the bottom using PEC 200, meaning 200 kilonewton. And the top of the wall, we use PEC 150 kilonewton. Okay, the next one is still same from the slope reinforcement. This is for downside for slag in PT Inco Nickel Sulawesi. Also, it's already 10 years ago, more than 10 years ago. We can see here that the PEC 100 and PEC 150 installed layer by layer, and show how the installation doing in the site. Okay, so the next one is just share to you the application of prefabricated vertical drain. This is for the infrastructure for the Sumatra Forward. That we know that the Sumatra now is under intensive to be finished by this year or next year to go to some section in Sumatra. So we install PVD, and also we install also PET to the embankment reinforcement. Okay, another application is for hydraulic. This is for reclamation. We use polyfed PEZ as basal reinforcement and hydraulic. And the next one also I would like to share to you the geotube application in Indonesia. This is a very popular, now become very popular product. We install this 10 years ago in Sumatra for power plant. We can see from the picture, and sorry, the picture is not from my side, I think from this website. Okay, so we can see from the drone that the geotube is under brick water to be replaced armor rock and to be a core of brick water. And the last application in Indonesia is for lining. We use the geosynthetic liner. It's made from natrium or from sodium bentonite to be the impermeable liner for lining. Okay. Okay, so the last project front, I think the next presenter will talk more detail about this geotube geowatering in South Kalimantan. I will pass this one. And okay, I just want to take like few minutes on the global project that already award under IAA, International Achievement Award. This is organized by IFAI, Industrial Fabric Association International. And one category is under Geosynthetic project. That if we can see from the picture that from year to year, since 2010 until 2019 last year, our company always have the award, starting from the project in the Incheon Bridge 2010, then going to the one project in the Gansu province in China for slope reinforcement, then geowatering in the Singapore, Tianjin Eco City, China. And the next is also for the project in Santos, Brazil. And 2014 is one project in Chile. 2015 is one project in Haiphong, Vietnam. So if presenter attendants or participants want to know about the detail of the product in Vietnam, I think please contact us and we'll see the detail of the project. 2016 for the landfill application. 2017 is in Indonesia. And the last is 2018 is for Yuxi Municipal Solid Waste for landfill application in China. And the last one is Davao City Coastal Road Project. I think this project is for the last one I saw in the YouTube. So if participants want to know about the detail of it, please go to the YouTube, because Tankato already said this very good YouTube for this application. Okay, so I think I finished already all my presentation, and thank you very much, and please enjoy this all webinar. Thank you, Mr. Hadi. Now the time back to you.
Yeah, thank you, Pak Doyo, for a quite nice presentation about introduction of Teknik Geosynthetic and also geosynthetic application for mining sector. So for now, before we begin for the next session, I would like to inform you some points to note for this session. So for this session, the next session, with Mr. Brandon as the presenter, all of the audience will remain mute throughout the webinar. And then the second one, please send your question to us via the Q&A tab, because for this session will be all the participants can send us the question, and then we will open all the Q&A tab shortly, and the Q&A session will take place after the presentation. And the last one, for this session, the video recording and presentation material are available, and you can get it after the webinar. And then the certificate of participation will only be sent for those who present in this webinar. So if you are joining this webinar without sign in into Teams account, please reply our reminder email that have been sent to you before, to acknowledge that you are interested to get the certificate, and your email will be count if you send during this webinar. And we strongly suggest for the Q&A, we strongly suggest you to put the question without anonymously, so we can reply your question if the speakers cannot reply it directly in this webinar. So after the webinar, we will try to answer all the questions that haven't been answered by our speaker. So for the next session will be brought by Mr. Brandon Swift. Brandon has involved in the geosynthetic industry since 2001 and has sales and marketing experience across the range of geosynthetic application and function. From 2005 to early 2020, Brandon was the managing director of Geofabric Australasia company, and then leading their operation across ENZ. Prior to this, he was managing director of Macaferry Australia from 2003 to mid-2005, and now he is the business development director at Teknik Geosynthetics Asia. So shortly, Mr. Brandon will bring the presentation with the topic geosynthetic application for closure of mine tailings and sediment ponds. So, Mr. Brandon, if you already have the control, please start your presentation. Thank you.
Thank you very much, Hardy, and good morning to everyone. For some of us, it's good afternoon, and for a few ambitious people, it's good evening. I think there's a few people from the different time zones. So today we're going to talk about the closure of mine tailings and sediment ponds. And just to start off, I want to be clear that we're not confusing the closure of ponds, or in fact the capping of ponds, with the closure of mines. I mean, mine closure is a discipline in its own right. It's quite broad, and it's generally done over many years, and there's a number of materials, some references on the right there, but there's a number of materials that can explain what mine closure is. Today we're talking about the closure of mine tailings and ponds, and that very well may be part of a broader mine closure. And to just set the scene, in mining, water management is very important, and every mine site will have their own issues. So generally in mining, you've got either too much water or not enough. You might have it in the wrong location, or you may want to reuse it, but it's too dirty or contaminated. There's a number of challenges, and you have got your own terminology as well about what type of ponds you have. So you can see I've listed out there a range of names that mining companies or mine sites will call their storage facilities, and I'm sure there's many more. And some photos on the right will show the scale. So they can range from being reasonably small, say 30, 50,000 square metres, all the way up to being 300,000-400,000 square metres in size. So the key point here is every mine site is pretty unique in its water management issues. But generally, there's a number of ponds on a site. So if we look at a water or liquid containment pond on a mine site, geosynthetics can be used in 3 different applications. The first is when you're actually building the pond. You may use geosynthetics if you're lining it, so things like geomembranes or GCLs, as well as other materials. And then when the pond is in use, you may want to be dewatering it, removing the sediment or sludge from the water. So you can use geotube dewatering, and occasionally, if you're more towards the end of life, you might be looking to dewater it using PVDs perhaps. And at the end of the useful life of the pond, you may wish to come back and cap it, and that's where we'll be talking today. And there's two solutions that are used in capping of a pond. You can either cap it with a lining solution, such as again membrane or GCL, and that's pretty much done to make sure the rainwater coming in does not get into the sludge underneath, or alternatively you let the contaminants below come up. Or you may be looking to reinforce the top of the pond, which will be the focus of what we talk about today. And essentially what you're doing there is putting soil on top of a very, very soft sludge. And why would we want to close it or put a soil layer on top? Again, every site will be different, but there will be a number of reasons that could apply. You might operate in a country where you just have to do it. It's part of your mining license or regulations. You might be part of a global company and have your own internal frameworks to work within. It might have a safety or environmental aspect, such as you don't want, after you leave site, you don't want people wandering in or livestock wandering in and falling in the pond, or the pond itself overtopping and emptying into the river. So there's a number of reasons that you would actually close the pond down. So this is the classic situation where you've got your pond wall and your saturated sludge inside. One way of putting the cap on is actually, rather than just using the saturated building on top of the saturated sludge, is to dewater it, and that'll be the discussion around the next talk. But not all sludge actually dewaters that well. It might be that we've put it in too quick, or you're in a high rainfall area, or perhaps that the nature of the sludge is such that it just doesn't consolidate. So today we're going to step through the solution where we're putting a pond capping, or for example in our case a metre of fill on top, and we're putting a reinforcement solution on top of that sludge so that we can build on top of it. So the problem we're trying to solve is moving from this application or this solution to this, where you can see that we've put a soil layer on top of the saturated sludge and allowed the vegetation to come back, and the landform returns to some form of original vegetative environment. And the red line there signifies the geosynthetic reinforcement layer. So we want to get to this solution without this happening, where you think you're building on top of a stiff crust, or on top of drier tailings that actually, or drier sludge than is actually there. And of course what happens is you break through the crust, and then you find yourself in trouble with machinery or people starting to sink down. So that's what we don't want to happen. And here's an example of what we'll be talking about today. So this is a mine site in the Northern Territory in Australia. On the left is what it looked like many years ago, in the turn of the century, at 2000, and you can see the pond was in action. And today it's back to a natural landform. So they could have just filled that up with sediment and then built on top, and they could have dewatered it out, or they could have capped it. But at the end, what their intent was to get a layer of soil on top, and so they can revegetate it. So that's the situation we're talking about. So if we've got a pond with very soft sludge, we need to be able to get construction access out there over to place the reinforcement solution as well as place the soil layer. So we need that. That's why the reinforcement layer is there. It needs to separate the sludge from below with the material on top. It needs to allow water flow, and it needs to have good tensile strength. And the number or the strength of the material we'll select during the design phase. And the other point is we've got to make sure we've got a continuous sheet of reinforcement. So whether we supply the reinforcement solution in panels or rolls, during the construction phase, we don't want the adjacent panels or rolls to come apart. So we'll talk a little bit about seam strength and overlaps as well. And Team have been offering solutions for pond closures and pond cappings for decades, and the proven reinforcement solution from our perspective is a high-strength woven geotextile sewn into large panels, and the sewing can be either done in the factory or on site, but we'll be talking about a high-strength woven solution today. So the best way to step through is maybe take quite a simple example, and then we can move through the 6 steps. So for today, let's just assume that we've got a sediment pond on a mine. It's next to a river. We don't want it to overtop or fail and go into the river and impact the downstream communities. It's a relatively small pond, so 30,000 square metres. It's, that's sediment depth 4 metres, and then the freeboard, that is from the height of the water level to the top of the dam bank, of 1 metre. So the decision has been made that we need to close the pond. We don't operate under any regulations that would mean that we have to line the cap, so we can use a 1 metre thick cover layer. You can call it a store and release cover, but essentially what that means is a thick soil layer that, as the rainfall comes, it's stored within that layer and then is released later, so that the rainfall is not going through that 1 metre thick cover layer and into the sludge beneath. So one of the advantages of being able to use a woven geotextile is generally we can take the mine overburden waste and use as the cover material. And there might be a few selection characteristics around that, but what it does do is enable you to use existing materials. So what we'll do now is just step through our approach and see how we can solve the problem. So in simplistic terms, there's 6 steps. The first 3 all relate to what's going on site. So what's the characteristics of the sludge, what cover materials or equipment do we have, and what are the pond dimensions. The 4th stage, obviously, the design phase can be done at the desk, and stages 5 and 6 is where they start to move beyond design and actually out into the field and dealing with the contractor and all the practical considerations around buildability, safety and so forth. And on the right hand side you can see that this is what the characteristics will influence. So for example, the sludge characteristics will determine the strength grade, the construction method and so forth. So there are reasons for determining the inputs. So if we start with looking at the sludge, you can look at the pond and you can try and determine that if your crust is stiff or soft, but that's the best way to do it is, or the only way really to do it is to actually determine the undrained shear strength. It's one thing to look at it, it's another thing to know what's going on beneath the surface, as well as how consistent the undrained shear strength is across the pond as well. So if the actual geotech report comes back and says you've got some reasonably good strength for that crust as well as beneath it, then the simplest and cheapest method is just to build on top of it. Option 2 is where it's kind of middle of the range, and you may have solutions where you can stiffen it a little bit. So you may dewater the sludge, or alternatively, if you're confident, you may want to have the geotech people look at placing thin layers of dry tailings and building it up. But you'd want to know for sure what's going on beneath the surface. But there are many instances where that sludge is actually either soft on the surface or soft beneath the surface, and you need to reinforce it. And that may be in instances where you've actually filled that pond quickly and it hasn't allowed the material below to evaporate out. It might be in high rainfall areas, or it might just be that the poor consolidation properties of the sludge itself. But option 3 is where we're looking today. It's a proven solution. The installation is a little bit more complicated than the other solutions, and it is also a little bit more expensive than the other solutions as well. But the key point is when you're building on soft sludge, sometimes it may be the only solution. And the point about the geotech report is that if you break through the crust, you may find yourself in a lot of trouble. And I showed the photos before of the mining vehicles. And here's a video where this chap is out on a pond, standing on the crust and thinking it's pretty strong. But if you watch him, I'll just try and play that again. You can see as he punches through the crust how soft it is underneath, and with hindsight perhaps he should have been wearing a safety harness or similar. But you can see the point there that whilst that crust looks stiff, in actual fact underneath it's pretty weak. So you'd want to know the undrained shear strength of the sludge. There's a couple of ways of doing it, but the in situ vein shear test is the best way. There's also other ways, like on the right hand side there you can see them taking some test results across what looks like a pretty weak surface. A high quality geotech report at the start will give benefits later on. I think it's all well and good to have one result, but you'd want to know across the width and down the depth at a number of locations exactly what we're dealing with, because that'll yield what we're building on. So today we'll just assume we've got a very low undrained shear strength, therefore we need to use a reinforcement layer. The other influence will be where exactly is the water in relation to the sludge. So on the left hand side you can see there the water level sitting pretty much at the saturated tailings level or just below, whereas on the right hand side there are going to be mining ponds where there might be 3 metres of water depth or 5 metres of water depth above the tailings or the sludge. They're very, very different construction modes, and they bring different challenges. So for the purpose of today, in keeping it simple, we'll assume the most common solution or application, which is on the left hand side where the sludge is actually sitting above the water level. And you can see that'll enable us to access the surface far more easily than on the right hand side. Another detail we should determine with the sludge is the pH, and this is more just a check for short-term durability. So with a mining pond closure, you might be dealing with environmental regulations that'll start talking in hundreds or thousands of years, but the geosynthetic reinforcement is not required for that long. So the geosynthetic reinforcement is there for the initial years in terms of durability, and is there mainly to take up the load during the construction phase, because over the longer term, the actual cover layer will help put downward pressure and push the water out of the sludge below, and it'll stiffen it up a little bit. But the key point is that the geosynthetic reinforcement has got to last, perhaps a year, and it's got to be, given that geosynthetics are made from polymers, it's got to be compatible with the pH. Now, the chemistry of pH will vary. This is a good paper. It generally outlines the different liquors or outputs from the mining processes, and it then correlates that to the common polymers that geosynthetics are made from. So for the point of today, we'll assume a pH, pick a value of say 3 or 4, which is generally well accepted for the impact on common geosynthetic polymers. Having said that, we are looking at jobs with pHs as low as 1.2 and 2. So it's just a matter of having test results available. But for the point of today, we'll assume the pH is pretty plain vanilla. Step 2, just want to check determine the loads, and the loads are coming from 2 areas, one of which is the cover material that we're putting on top. So that will be what run of mine waste have we got lying around the site that we're going to use in that 1 metre thick layer. And also, if we've got some details around it, we'll be able to understand any installation damage, strength reduction factors and so forth that we can use. And I'll show you some photos of why. I mean, high strength woven geotextiles are quite accepting of big angular rock, but notwithstanding that, we've got to take into account what the cover material is, and as well as the impact it has during the construction phase. And then the live loads. So in this case, that's the equipment that's being placed on top. And again, for mining sites, it's generally you're generally starting off trying to use the equipment that's on site and not trying to bring other equipment in. But that'll all be factored into the design phase. So for the point of today, let's just assume that we have a 300 mil drainage layer, and then we put a 1 metre thick capping on top, and we're making that capping layer from the available overburden or mine waste, and we know what construction machinery we've got as well. So this will give us the inputs into the design phase. Next is we've got to understand the pond dimensions and how they relate to the geotextile panel sizes or a little bit in the buildability phase. So we'll assume a pond of 100 metres by 300. It's not very big. Some dams, as I said before, can be 200, 300,000 square metres or bigger. We can supply high strength woven geotextile in reinforcement in panels. From the factory, the benefit of this is the seam strengths achieved in factory made panels are higher than on site, and seam strengths may play an important role later on, which we'll talk about during the construction phase. So for this pond, we are able to make rolls of 125 metres length, so longer than the 100 metre length, and panels of 25 metres wide. So that's 5 rolls stitched together. So in this case here, we would need 9 panels. Now the 9th panel may not be 25 metres wide, but you can see the logic that take the pond dimensions and start to figure out how many panels you need. So now we step into design. So we have we've got our knowledge around the sludge. We've got our knowledge around the loads, as in the machinery loads and the construction and the cover material loads, and we understand the dimensions of the pond and the panel layout. So we're going to design using tension membrane principles, and which essentially means, as you can see here, that as you put load on, you'll get some deformation, and you're placing that reinforcement layer in intention, and that's the design method will reflect this. And you can also see there'll be, as I said, deformation. The sludge will move, and we'll show you some of the impacts that need to be considered later. So in terms of design, I'm not going to step through it. What I will point out is there's 3 very good papers. They all build on each other. So from 87, 99, 2008, and the 2008 paper actually gives a worked example as well. And these papers provide a good basis for design. And they can also support your own design methods with your own software, or proprietary software. So you want to be looking for the local and global failure. And in this case here, you've got it's a fly ash pond. You've got a 1 metre thick layer using a woven. In this case, it's an RS580i. You've got your dozer on top, and essentially you're checking that you've got the right factors of safety. So the key point is that there are established methods for this, and they're laid out in those papers, and you can support that with your own checks through software. Now, if the sludge is very weak, as the cover material is placed, you're going to get stresses along the seams. So the seam strength needs to be understood. And I mentioned before that factory seam strengths can get a higher result than in situ seaming. This is where you need to understand or apply judgment that, for example, in situ seaming, you can do trials, and you might be getting 30, 35%, maybe 40% of the strength across the seam, depending on the capability of the stitcher. In the factory, depending on the capability of the teams, you can get north of 50%. So the seam strengths play a role in the design as well as overlaps. And I'll show you a little bit about overlaps later, but in essence, that's to stop the panels moving whilst there's settlement. And the berm dimensions and spacings will be confirmed through the design process. So I'll show you some photos of what the berms look like, but essentially all that's taken care of through the design. Step 5 is we're now moving into the practical side of it. You can see on the right hand side, that's a panel that's for the Hong Kong Airport project, recently been completed. You can see that when you're talking about panels that can weigh over over 1 tonne, over 1,300 kilos or more, you need to have a detailed understanding of how you're going to handle this at each stage. So how you're going to handle it in the factory, how you're going to handle it in and out of containers. Open top containers are generally used on road transport as well as on site. And this is more around safety, but it's also making sure the panels don't get damaged along the way. And the last step is actually where all the construction tips and tricks come into it. So we'll talk about installation a little bit, and then I'll show some photos and a couple of case studies. But spending a bit of time thinking it through about how to construct it and getting it right in the planning process will make life a lot easier when you actually come to build it, because it's a bit hard when all the panels are on site and you're trying to pull it across and it's not quite working. So this is a bit of a summary slide. You can see that if they're the panels laid this way, you've got seams, you're putting some anchorage load around on the panels, and then you're working perpendicular by pushing out finger berms. And that's where I said before, the dimensions of the finger berms and the spacings can all be worked out in the design phase. So let's just go through quickly, step by step. This is plan view. The panels will be delivered to site. They'll need to be unfolded, but essentially what you've got here is the pond walls and the saturated sludge. You're then rolling the panels out. So you can see here that you have overlap with the edge. As you've rolled it out, you'll probably want to ballast the edge to resist uplift. You've then taking the next panel out. You want to overlap the panels. In this case, I've mentioned 1 meter, but that's just a number. The key thing is, how are you going to pull these panels out? Remembering these are 125 meter long panels, so you need a lot of planning around what equipment you've got, how you're going to pull it so it doesn't damage the product, and you've also got to make sure it's being laid accurately. Having got it in and having anchored the ends, remember that we had a 300mm sand layer, so we then start to place the sand layer over the geotextile, working perpendicular to the principal strength direction, which is from left to right. And as after we place the sand layer, we then start to introduce the tensioning finger buns. Now, what they do is start to tension the geotextile. So this is the principal reinforcement direction, and by working out this way, you slowly put it in tension, and that way you're not overstressing it. So you need to move carefully, and you can see there the lightweight dozer, but obviously we've done that design to knowing what equipment we've got that we're working with. And then having put the buns in place, we can then fill in between. So in essence, you're filling in the palm between the fingers. And then you progressively keep going forward with your sand and your finger buns and then filling. All the time working perpendicular. So if we step through now a number of photos just to see these concepts in action. In this case here, it's a single panel, big rolls that are you can see the seams going this direction and being pulled across. See the webbing that's pulling it across. Because it's going on the water, you've got floats on that leading edge. And that's one way of getting it across. Here's an example of the soil layer being laid on top. You see a little bit of a mud wave there, but working perpendicular to the principal reinforcement direction. But you may have instances where you don't have a soil layer. You may just want to go straight into the tensioning buns. In this case, it looks quite small, and you can see the seams running up from top to bottom and just coming across from either side. And that's quite a valid way of approaching it as well. And the point of this photo is to show that sometimes the mud wave can be quite significant, and if you're putting load on and the sludge beneath is moving that much, you've got to be able to ensure that your material stays together. So those seam strengths are important and need to be considered so that you're not having gaps open up within the reinforcement layer. And an aerial shot of a project in China where all the panels are laid out. You can see some ballasting probably for uplift. That's all buried in around the edges for anchoring trenches, and then progressively moving out with the material so that you're progressively tensioning putting the reinforcement into action. And in this case, they're working from the side, but there's also some equipment moving slowly out, pushing the materials around. So I've got 3 case studies to show examples of what we've just talked about in action. This is one in the US where you think you've got a good crust and you open up beneath and it's just sludge. So in this instance here, you can see the equipment coming in. You've got rolls of woven geotextile. In this case, it looks like it's only 2 rolls wide. There's one seam down the middle getting pulled out. There's the seam there. They're pulling it in a certain way such that the material doesn't rip or tear. and just pulling it out progressively, placing it down. Again, you can see the seam, and then you know that you get that separation, you get strength, and you also get some, you know, the water or the liquid coming through as well. So you get that release of pore water pressure. And the point I made before about the use of cover materials and how you know, wovens, geotextiles can be quite accepting of a broad range of materials. If you look here, that's quite big rock being used. Quite, it's going to have a bit of impact on the geotextile as it's placed, and you're not going to get that with many other geosynthetic solutions. So this is a great photo showing, in this case, no drainage layer. They just took the existing run-of-mine waste and pushed it back out and created a soil cover on top of a woven geotextile as reinforcement over a weak sludge below. Another example is in Spain, a tailings pond that was being closed, a reasonably large one at 350,000 square metres. You can see there that the material was very soft, and they were going to build a 1 metre thick working platform on top. So this is a bit of an aerial shot showing the reinforcement layer being installed. This is the cross section, so a 400 kilonewton reinforcement layer, 400 kilonewtons in both directions, with a 1 metre stone working platform. Again, you can see the type of stone used, so not as big as shown in the US example, but still reasonably large. And the difference here was, once they had the working platform in, they then built up another 1.5 metres or more, but they had to line it, and they had to put in a geomembrane liner to stop the water coming down and getting into the sludge below, as well as contaminants coming up. So slightly different, but in this case, looking at the reinforcement layer, it was holding up nearly 2 metres of soil on top, and obviously did the job on very soft tailings with construction vehicles working on the top. And the last case study is a mine pit closure in Australia, and you can, at the start I said we're talking about pond closures, not mine closures. In this case, the mine was being closed, but you know, you can see there from 96 to 2008 they were filling up this pond, and you know, sometimes mine closure is done progressively over decades. So they're actually doing it whilst they're operating. So in this case here, they were planning ahead for closure whilst they were placing their waste. They came back 2012, put some PVDs in, came back a few years later, and then put in the high-strength geotextile layer. So in this case, it was a biaxial 150 kilonewton Marafi PT or polyester woven. Again, a reasonably big area. So the cross-section, there's the tailings, there's the reinforcement layer, so the PVDs were coming 40 metres down. So the reinforcement layer was placed in a 2.5 metre rock cap, and that took care of all the rain that would come in, get stored and then evaporate. Now, obviously with PVDs, as you put the waste rock on top, it pushes down and then the water comes out and you stiffen up the sludge below. So the stitching was done on site rather than in factory, but the photos will show why. It's quite a big area. So that was it, 2000, obviously, a little liquid. This is what it looks like, 15 years later. The first stage was putting the PVDs in, a little bit tricky. They had a barge, big mast, punching the PVDs down. So you can see that in this case, the water level was above the sludge. The high-strength woven that was delivered to site was sewn on site to provide the seams, and then it was progressively laid out. So you can see that whilst it had now provided a bit of a crust, compared to the water before, the machinery and the rock layer would have gone punched through that crust. So they're putting the reinforcement layer down and slowly working their way across. You can see here the reinforcement layer, just building across, a little bit of a closer photo. They had multiple layers of geosynthetics. The black layer here is just a cheap slip film woven on top of the PT 150 kilonewton biaxial reinforcement layer. And this is probably the photo that shows it best, where they've actually got the reinforcement layer being installed and putting the finger berms in and then filling in between. So slowly working their way in from around the edge. And that's what it looks like today. So that's the end of my talk. Hopefully you learned a little bit around reinforcement of a pond closure capping. And I'll hand back to you, Hardy, and thank everyone for their attention.
Thank you, Brendan, for your nice presentation. I think untuk teman-teman dari para peserta yang dari Indonesia mungkin ingin bertanya, kami masih terus menunggu beberapa pertanyaan, namun sudah ada beberapa pertanyaan juga yang sudah masuk dan kami akan mencoba menjawab dari Brendan. Okay, Brendan, I will try to start the question and answer session for this topic. Some questions already come in. I will try to send to you the first one. It's from Guritno. Do you have application example on mine overburden or waste dump area?
There's two ways to understand that question. I presume you mean reinforcement of the sludge before you start placing the mine waste on top, the overburden on top, or alternatively, do you mean having an application where you've got the overburden area off to the, say, the right-hand side, and you're managing the water flow from there? So they're two different examples. I think with mine waste, they're generally working with big volumes. My experience has been they just take it to one side. They're not really looking to. You could, I guess, but I haven't seen it where they've reinforced the soil before placing the overburden heap on top. But there's no reason they couldn't do that. It's just that generally a mine site's got such a big area they can just push it off to one side. If you're asking a question more about you've got an overburden dump and you've got water coming off it and it might have acid mine drainage issues, have we got solutions for that? Then I'd say yes. We've done examples with YouTube dewatering around that solution. So slightly different examples. But if you did have a need, say for example you've got very soft sludge and you wanted to put the overburden waste on top, then there's no reason it couldn't be done. I guess it's just a matter of working with you to understand the heights, how it's loaded and so forth.
Okay. So the next question is, let me see, from Aprilia Mega. Do we are Teknik consider the determinant of external factor like groundwater table, daily or monthly rainfall in the area that we will be close, and what are the obstacles encountered during this method?
Yeah, I mean, Tenkate as a essentially at our heart we're a material supplier, so we provide technical support, but we do not replace the need for a engineering consultant that will accept all the design risk and so forth. So would we consider the groundwater table? For sure, you need to understand where the water level is. In terms of the rainfall, that will determine whether you can use a thick soil cover. You'll need to understand all the permeability of the soil and so forth. And in my eyes, that's the role of your geotech or your environmental consultant, because they'll also be looking at things like vegetation or chemistry as well. So I would say it's certainly an input to understand the rainfall, because that'll determine you know, is the cover, if you've got a store and release cover, is it thick enough, or alternatively, do you need to cap it with a GCL or a geomembrane? But that's not, Tenkate, I think that would be beyond what we would normally consider as our role in that project.
Okay. Okay, for the next one is from Mr. Trisupin. How you manage the post-closure so the failure won't be occur, and what is the mitigation, and how long the monitoring of the post-closure?
Yeah, so the it's probably links back before, where you know, as a solution provider, and our solutions come in the form of products. Monitoring would be outside our area of responsibility. So every mine site would have their own need or lack of need for monitoring post-closure. I'd suspect the more global companies would like to monitor it, either settlement or perhaps just trying to understand what's going on in there. But certainly that wouldn't be part of our discussion with them. They would be putting their own technology into play there. So hopefully that answers it. We don't have any. If the question is, do we have systems that monitor? Do we have a product that will monitor settlement and so forth over the long term? The short answer is no. But there are solutions out there that can be simply and readily available should the mine site wish to implement them.
Okay, then the next question is coming from Mr. Heru. What if my pond is really long? How you will close that pond that have the dimension is really long?
Yeah, so in the example I gave, we were talking about a 100-metre long pond, in which case we could supply panels in 125-metre lengths to give you some anchorage at each end. Now, in the manufacturing process, there will be limits to the length of the rolls that we can make, and that will change with the strength grade. So a 200 kilonewton strength grade, we should be able to make longer rolls than, say, for a 2000 kilonewton strength grade. So what happens if you've got a pond that's quite large, and we're working on projects like this where they're 500 metres long or 400 metres long? That's where it gets a little bit complicated, and that's where there's solutions such as maybe you've got to construct an internal bund wall before you can get to, you know, putting out the panels. But if you're unable to put out an internal bund wall, say for example if it's you know, hundreds of metres long and you're actually a couple of metres beneath the water surface, then accurate placement, holding it in place, making sure the overlaps are there, as well as the overlaps can handle the settlement under load. So it gets more complicated, but it's not impossible. It just requires a lot more thought early on with the designer and hopefully with the builder as well.
Okay. Because the time, I think this one is the last question, is coming from Mr. Sahrir. What is the cheapest way of closing the pond?
Fill it up. Fill it up with if you've got sludge that is reasonably dry and dewaters well, and you can just keep pouring material in there, then that's a cheap solution. In the example we were looking at today was where that sludge will not dewater, that sludge will not stiffen up over time, and you need to get off site for whatever reason, and you want to put some soil over top for safety reasons or environmental reasons. So the solution we were talking about then, today, was at the problematic end of waste in that pond. And if you've got the intermediate situation where you've actually still got some wet waste, and you want to dewater it rather than cap it with reinforcement, then stay tuned, because Sam's lecture now on geotube dewatering will show you many examples where mine waste is dewatered and is then capped straight without reinforcement layers or much other work.
Yeah. I think that's all for your session. All the questions have been answered. There is some question coming in right now, but I think the answer will be sent to you for all the attendee. So don't worry for all the attendee that you haven't got the answer from all the questions. The questions you still can post it to us and send it to us, and we will try to answer all the answer the question after this webinar. Right now, we will try to move on to the next session, that we will talk about tailing dewatering with geosynthetics. This topic will be delivered by Mr. Nur Hisam Umar. And before we begin, I will like to remind you all the attendees, all the participants, that for this session, you have to strongly take the points to note. The first one is your mic will remain muted throughout the webinar. And the second one is, please send in your question to us via the Q&A tab. If you cannot find it, you will find the icon Q&A in the upper right of your screen, and then the Q&A session will take place after the presentation. So the speaker will try to direct answer your question, but if there is a question that haven't been answered for this webinar, we will try to answer it after the webinar also. And again, we strongly suggest that you all of the participants to post your question not anonymously, so we can reply it, and if your question cannot be replied by this webinar, we still can send, and we know who we will be sent to. And then the last one is the video recording of this session, and the presentation material will be available and sent to you, all the participants that present in this webinar. Also, the certificate of participation will sent to you for who present in this webinar. And to remind again, if you are joining this webinar without signing into Teams account, please reply our reminder email that have been sent out to you before this webinar, and to acknowledge that you are interested to get the certificate. And your email will become if you send the email, if you reply the email during this webinar only. For the next topic, I will try to explain the short profile of our speaker, Mr. Nur Hisam Umar. He is the Regional Business Manager of Geosynthetics Asia, with graduate of the Bachelor of Engineering from University of Technology Malaysia. He has extensive experience in the development and manufacturing of geosynthetics since 1997. He took the leading role in expanding Geotube, our product, Geotube dewatering, and shortly he will explain it for mining application. And right now he posts as a Regional Business Manager of Teknik Geosynthetic in the Water and Environment Division. In addition to his expertise in dewatering application, technical design, and installation, Mr. Nur Hisam has a wealth of on-site experience with dredging equipment, polymers, and site management. He has involved in securing some of the largest geotube dewatering projects worldwide. So without delaying any further, we can start the last session of our webinar with the topic tailings dewatering with geosynthetic. I will give the control. Mr. Nur Hisam, if you already get the control, please start your presentation. Thank you.
Thank you, Pak Hadi, for the introduction. So, hi everyone, and also everyone. Selamat siang kepada bapak-bapak, ibu-ibu di Indonesia ya. Assalamualaikum semuanya. So, the title of my talk this morning is Tailing Dewatering with Geosynthetics. Geosynthetic dewatering using geotextile permeability material that water can easily flow through them. So in mining environments, we might not think we have also geosynthetics for dewatering solutions, but more often people are dealing with mechanical dewaterings like filter press or using thickener methods, or use of conventional tailing storage facilities which tailing generally discharge from the spigot. There is an option of using geosynthetics for dewatering in mining application that can be used, and we will looking into it, and I'll be sharing my experience on my next slide presentation. Okay, so my content of talk today, there is 5 topics. So I try to cover these 5 topics within 45 minutes and followed by question and answer. And the last topics, I will share some projects that we use for geotube dewatering application in mining. So move on the first introduction. If you look in the pictures on the left one, number 1, this is I consider large scale dewatering projects using geosynthetics dewatering. This is a project located at South Kalimantan, Indonesia. And the picture number 2 is one of my projects that's handling rare earths solids in Malaysia, so that we can stack up to 5 stacks layers. And the picture on the bottom one is another project that I have done for titanium to contain titanium dioxide in Malaysia. So this is another one example project for South Kalimantan, Indonesia. If you look into the scale of the project, this is how we can use geosynthetics dewatering for mining application. So Teknik Geosynthetic Groups has developed the geotube dewatering technology, process to efficiently dewater waste slurries such as dredged sediment, and geotube dewatering technology process has been carried out in many countries throughout the world. Geotube system is a special fabricated tubular containment unit made from woven polypropylene, designed for dewatering organics and also inorganic sludge. So geotube system is used in engineering application. And then I have to tell everyone that a geotube is a registered trademark of Teknik. So if you look into the pictures on the right, on top of this picture, you can see the woven geotextiles. It's a black colors. It's a permeability material where water can go through into them. So some of the advantages of a geotube dewatering systems. So one of it is alternative methods for storing dry sludge. And it's also effectively replace the need of tailing storage facilities. And continue with some of advantage of geotube dewatering systems. You can see there is lots of advantages. If I have listed number 1 until number 7, you can reduce tailing pond overloads. It also can be used for pond or lagoon maintenance, cleaning of the sludge pond, cleaning storm water runoff, And some of the projects that I have done in the past, especially on the gold mine, to recover precious ore for the later process. So you look into the geotube dewatering process. It's really simple. The sludge source might be coming from the settling pond or evaporation pond, or might be from the spigots that's direct discharge to the TSF. Then once we transfer this sludge into the geotube, in the between, we might be injected with polymer. Once the flux is worked in the pipeline and then enter to the geotubes, then water will coming out very fast and the solid will remain the same. As you look into the box number 4, this is what you're going to expect on the dewatering solids. You can see is hard like the rocks. Some of the project I have done, they will just cut and open and they use for other purposes. Or some of the client, they use a capping. Just once you have a dry solid in the bags, and then they just put a HDPE liners, and then they put a fence, and then they just grow grass or vegetation. So this is another option. If you have in mind to have a capping, either you want to have a Brandon presentation just now, there is another method of doing a capping, or you can use geotube dewatering technology to do a capping as well. So depending on the sludge that coming out from the geotube, if the water quality is permissible to direct discharge, it can be direct discharge to the river, or some of the application, because of due to the COD level still high, it might be go to the processing plant for further treatment. So mine waste usually starts within the mine sites, in tailing ponds, heap piles, or mine tunnel underground. There are few issues except for the waste rock, generally unsuitable for use as a structure fields, usually highly saturated or hazardous, and often not allowed to be discharged untreated to the environment. If you look into this diagram, this is a typical mining operation. For the participant who have a background on the mining, I'm sure you are more familiar on these mining operations. We have open pit minings, we probably have underground minings, and for the processing plant or the mill plant, normally they generate a lot of water. So this wastewater, normally they will channel direct to the tailing pond, and then as a storage. And then they have few methods on the conventional methods, where from the water discharge from the tailing pond to the river to the lakes, some of them they use conventional methods as a settling pond. Some they use a mechanical dewatering equipment. And then we have another one, what we call as a overburden area. So what is a tailing? Tailings are the products that remain after metals have been extracted from ore by physical and chemical techniques. It consists of solid and liquids, and solid typically in fine sand and silt range. So solid discharge with concentration typically from 25% to 45% of solid concentration by weight into tailing impounded. Spent processed water runoff is also discharged normally into tailing impounded, and is also particularly potentially toxic material. Some of typical characteristics of mine tailings for metalliferous ore. The mine ore is usually ground to rock flour, while coal is crushed for processing, thereby generate fines. Tailings are produced in aqueous slurry form with a very low solid concentration, and tailing particles tend to be angular in shape except for fly ash. Picture on top on the right, this is a sieve analysis equipment that's normally geotechs doing soil classifications. For some for mine telling, typically at the D50, it can vary from 5 to 100 microns. And typical specific gravity or SG solids for tailings, for example, coal, you could be about 1.5 to 2.5. Bauxite with much, it could be up to 3.2. Metalliferous is about 3, and pyrites is about 5. So this is a few examples of conventional dewatering methods that been used on some of the mining companies. They use chamber filter press. Some they use belt press or centrifuge. So mechanical dewaterings normally require high capex. They're difficult to be moved around. They need a lot of frequent wear and tear, breakdowns. Then the water cake also still need to be handled, transport and disposal. If you look into YouTube dewatering mechanism, it's really quite forward that if you have a sludge, you just transfer the solid into the bags and the water coming out and the solid will be retained in the bags. So one of the goods about this geotube dewatering is we are able to handle a very large sludge volume and rates. So look into the diagram on the bottom. Each of the geotube, once we predetermine the relative density, we will need to set the max fill height. If you look into the graph, so once we pump the tubes, and then we need to stop at the max fill height, and then let it water, and then we keep a continuum pump and let it water. Then this we call it as a geotube dewatering cycle. So how long, how frequent the geotube dewatering cycle needed, it also depends on how much the solid concentration been transferred into the bags, and we need to have a time for consolidation. So probably it takes about 4 to 5 weeks for especially for the mining to achieve around 45 or 55% on the final solid concentration. I will just talk very briefly on the geotube designs. If you need more information how we do the design, just email to me. I will answer all your questions here. So when we consider on the geotube design, there are 3 factors that to determine the cost dollar per meter cube dry cake. Number 1 is geotextile cube cost. We can convert on dollar meter cubic dry cakes that I will show you on the next slide presentation. On the polymer cost, it's about dollar per kilogram metric ton dry solid. How many kilos for one project particular? Let's say we have 500,000 meter cubics, or we have 1 million meter cubic. How many polymer that we required? And also the operating expenses. These operating expenses including the pipes, including the watering platform preparations, manifold, flexible hose, that is under operating cost. If you add up geotube cost, you plus polymer cost, and then you add up this operating cost, we can have estimates the total project cost on dollar per meter cube dry cakes. Is it too high? Is it feasible? Is it viable? So this is one of the good benchmark to determine whether you want to have a geotube dewatering system in place. So when you start design, there are 3 stages to consider. If you look into the diagram below, so we have to consider the volume in situ. So how much volume on in situ, and then what kind of solid concentration in place. Is it 10%? Is it 20%? And then we need to know the SG solids in situ. Because we need to know the SG solid to calculate, to determine the volume of the sludge. So once we know how big the volume, the scale of the project, and then we can do the sizing up of the pump, especially of the dredger. How big the dredger? Are we going to pump 500 meter cubic? Are we going to pump 1,000 meter cubic per hour? And then the third stage, once we have the in situ sludge, we know how much solid been transferred. We can determine the final dewatering cake volume. So this is three, at least minimum information or inputs that we need when we start to design on the geotube. So once we know what's infill material related density that we're going to use, we know what's SD solid that we're going to work, so we can predetermine the safe control maximum fill height. And then we can predict also how many dewatering cycles we needed. And then using some tricks on the mass volume analysis or equations, we able to know whatever we pump in, and we can also determine how whatever we pump out, including the effluent. As you know, for mining, the effluent, the water is very critical. So having this kind of technology, geotube dewatering technology, you also have can recover a lot of water, the water coming out from the geotube. So this is typical work examples. One, we have all this data. We know how many volumes. We know what pumping rates that we're going to pump in. And then we can determine how long, how many days tubes that's required for a particular project. So for geotube size and analysis, for large tube, more than 8.8 meter circumference, we do circumference seaming. So we can make any circumference, any seams, and the tube length must be multiple of full panel width. If you can look into this bottom diagram, so each panel we going to have what we call a circumference seaming, to add up whatever length that you needed on site. So to have scale of the single tubes on this picture, this is I consider one of the largest tubes that we have installed and commissioned in Indonesia. The length of this single tube is about 101 meter length, and the circumference is about 36.6, and then we pump at the max fill height about 2.7 meter height. So for geotube dewatering platform, if you look into the left diagram, it's very straightforward. You have to have good solid foundations. It has to be flat, and then it must be surrounded with drainage, to make sure that the water is not going to have ponding area at the dewatering platform. If you look into the picture on the right, so you can see how we lay the incoming slurry pipelines. We have a manifolds, and then from manifold we have another flexible hose that's connect to the inlet geotube. So this is typical geotube dewatering platform. This is a very good example. You can have this kind of setup. You can look into this picture. The length of the geotube is about 61.4, and the width is about 36.6 meters. So once you're going to start to consider geotube for stacking, we Teknik always advise the client that they need to have to engage geotechs to have a SI. So once we go from one layer to the next layer, this is some of our standard procedure. That's we need to do SPT, or we call it as a standard penetration test. We collect some UU data at different soil layer, and probably we go to the minimum of 30 meters. So once we're going to go for third, fourth layers, and then we're going to have another test. So we have to check for each tube on the moisture content. We need also to check on the bulk density, friction angle, in situ pressure, UU pressure. So I will not discuss on detail on this. If you have any question on this first year, just email and let us know. So this is you can see in this picture. If you have to compare, there's one guy over there. This is considered last stack layers that we have done in Indonesia. Yep. Chemical conditioning. This is a good guidelines. There are three possible scenarios when you start to use chemical conditioning. So either they will no polymer at all that we required, or might be they need one or more flocculant applied without prior coagulant application. One or more flocculants are applied after coagulant application. If you look into the diagram on the bottom, on the horizontal, that is a particle size distribution. So anything more than 100 micron, that is more on sand. That we normally no need to have a polymer. But if you are talking the range between seed and sands, normally about 10 to 100 microns, these instances normally possible you need to have a single polymer. But anything less than 10 micron, there is what we call as a colloidal state. You could need to do a treatment to have a coagulant first, and then you need to use a flocculant. So most of the projects I try to have single flocculants rather than to have a coagulant and flocculants. Yep. But we can do upstreams to have when we receive a sludge to pump into geotubes, that's at the pH 7 to 8 that we might need to have a single flocculant. I will talk about coagulant and flocculant on the next slide. So coagulants are used to neutralize, to neutralize the pH. Flocculants are used to breach. Once they are neutralized, so what's a flocculant? It's going to breach between the fine particle, and then it become bigger fines, what we call as a flocks. Coagulant, if needed, I always use ahead of flocculant. So have to remember this. Coagulant have to do first, and then you follow with flocculant. But some modern polymer function, both are can work as coagulant and flocculant. So this is example. If you look into this diagram, so most of the fine sludge I can represent, they having a same charge. For this example, let's say the fine particle, they have having negative charge, the electrostatic negative charge. So when you introduce coagulant molecule, so it will extract, it will pull the fine particle to be neutralized. So if you look into flocculants, so once you have neutralized after you use a coagulant, you start to introduce a flocculant. So what flocculant will do, they will supply a long chain molecule around this fine particle, and then it become bigger flock, or we call some they call flock, some they call flower. I'm not know why. So this picture says a typical sludge. When you start on the far left, there is a raw sludge that's haven't treated, then you can see it's very fine. Once you start to have a coagulant be added, you can see the fine particles start to grow. And then once we have a pH about 7 to 8 after coagulant, and then you can start to apply flocculant, and you can see bigger flock being formed. So we need to have big flock like this before we pump sludge into geotube. So this is a very good guidelines. So once you have how you want to get right flocculant, yeah. So are you using coagulant before? Are you using no? Is it a pH below 6 or pH more than 6 or is less than 7? Or we might be end up with medium cationics. We might use anionics polymer. So this is a good lines how we want to achieve a good flocculation. So if you look into the picture on the top right, in the markets, we have powder polymer, or we have liquid polymer. So normally powder polymer from the manufacturer, they come into small bags, about 25 kilogram bags, or they come in one big bags, about 1 ton. Or some of manufacturers, like we supply liquids, they come with 1 meter cubic of two tanks. So cationics or anionics, this is some that we normally use for the mining. Cationics, they have positive charge, and anionics, they have a negative ion charge. So if you look into this picture, so what's determined a very rapid dewatering rate is the polymer dosage. So if you get the right polymer dosage, and then you're going to have a bigger flux. So from time to time, when we inject polymer on the pipelines, we have to really monitor on the polymer dosage to have a big flux. So if you look into this picture, when we start with 0 ppm, that is a very raw, and then we start to have 12.5 ppm, and then you can see the flux start being formed, and then we have 175 ppm, and then when we start at the optimum 200 ppm, you're going to have a big flux, you have a clean water, and then we have a very, very strong flux. So I share with you some of the projects that I have done where the installer have constructs polymer meltdown units. Picture number 1, they have one stainless steel, or maybe they have you can have not necessary to have a stainless steel. On the top is where you prepare the polymer preparations, and then you transfer to another stock tank. So we also have the second one that is I consider is a fully automatic. They have a sensor that equipped with to control the polymer. Everything is automatic functions. So the watering test. I will go through quickly on the watering test before you start any project of dewatering. So lab test and field test. Why? What the purpose to have lab and a field test? So once you done lab test and field test, at least you can answer some basic questions concerning geotube dewatering is what is the final dewatered solid concentration. We always want to know what is the final one, how long does it take to reach that final dewatered solid concentration. So what is the solids containment efficiency? So how clear is the effluence, and is it polymer improve or does it improve? So what kind of polymer, or what kind of coagulant, or what sort of polymer dosage required of the. So by having a lab test and a field test on site, so we can have generally understanding on what kind of the sludge that we are handling. So Technical have developed what we call as rapid dewatering test. So this is what we call as a quick test, yes and no. What type of polymer that we're going to use? So how much polymer dosage that we required, or we call it also as a fabric cone test. So once you have sludge in the labs, we can look on the water clarity. We can also understand on the water release rates, the flux, and is it a small flux, is it strong flux, is it a weak flux. So during the fabric cone test or RDD test, we can at least to understand on the sludge characteristics. So there is a second dewatering test that Teknik have generated. We call it as a geotube dewatering test, small kilo bag test. So what we do with this test, that if we have a pail of sludge and then we just mix these polymer solutions and then we just manually stir to make a flux. Then once the flux being formed in the pail, and then we just pour into the bags, and then let's see what kind of water clarity, water release rates, and of the watering solid content, and we can also predict on the final solid dewatering test. So once we done on the RDT, we done with the GDT, then we can go to the next level. We normally to have a pallet hull tube test. So the pallet hull tube test, what you can see is you can understand more. You can see how tube behave when you pump at a certain pumping, right? So this is good to have a pallet hull tube test. So normally we have a standard pallet hull test. So we can have small bags. We have a circumference 8.8 bags with the length about 30 meters to have a rental on site. So as a summary on the dewatering test, if you look into this picture, before we go for the full scale large tubes up to, let's say, circumference 36.6, it's good that we can understand more on the sludge characteristics, on how it behaves on the geotube by having RGT, and then we have GDT, and also we have pallet hull tubes. So we can supply some material on a pillow bag if anyone on the participant that you want to have a trial on site. We can just contact to Teknik Jakarta office. Might be they will deliver some of pillow bag for your own testing. So I will take a few minutes talk about on geotube dewatering application in mining. If you look into this picture, these are some projects we done in Indonesia. And the first case study here is about coal mines for the watering of settling ponds located in Indonesia. So the challenge of these projects, mines required their settling pond to be dewatered and reducing the need for more ponds. As you can see in the picture, the tubes we supply is over 100 meter long, up to circumference 36.6. So geotube dewatering for this project, they minimize the footprint and recovered the water for use in the mining process. Here's another one project that I have been done in Malaysia for titanium dioxide plants to contain gypsum. So what happened to this project, that due to the demand spike, there is the increase of production increase of production demand. So the existing filter press could not be coped. So one of the option, one of the alternatives, they having two parallels. So they have a mechanical dewatering still on the filter press, and then they channel about 60% of the sludge coming from the process to the geotubes. So this is the solution that we give for this project that is created that require increased wastewater capability. I have write a technical paper on this. If anyone interested on this starting in the site, please let me know. So another one that I have done projects for geotube dewatering is to contain rare earth mines for dewatering of settling pond in Malaysia. So the challenge of these projects, the long-term waste storage was complicated by the lack of free land space to accommodate the growing waste stream, while it's also ensuring correct handling and storage. So over 1 year, we have supplied about 100 tubes, dewatering tubes, using 36.6 circumference up to 50 meter long, and we are able to stack 5 layers. So we are capturing more than 180 meter cubic of dry cake within the tubes. Very interesting. If you look into this picture, on the top left, that is where the 5 stack layer tube been installed, and the pictures on the next, that is once they achieve on the final solid concentration, when we cut and open, as you can see, the sludge is still intact. As you can see, the profile of the circumference seamings from the geotube. So from big projects, then we come back to the small scale projects. This is another project for the gold and silver mines for dewatering of sediment pond located in Indonesia. So the challenge of these projects, the mine waste pond has become heavy silted and become a bottleneck in the mine process flow. So for having geotube dewaterings, you can dewater the sediment, allowing the pond to continue receiving waste. If you look into this picture on the right, you can see for these projects, the client can reprocess for the water cake to recover mineral bags. So this is one of the advantage having the geotube dewatering. This is another project that I've been involved for postpaid mines for acidic wastewater sludge dewatering in China. We also have done with a bauxite mine. So I have done a trial in Australia. This is very interesting. Even this trial that we have found a bauxite mine without having a polymer. If you look the quality of the cakes after we cut and open, we can achieve very good final solid concentrations. And then we have another one from Finland for nickel mines, the big projects for emergency water treatment plant. We have similar project for coal mines in United States. Yep. For copper mines, normally they have small sediments for stormwater retention basin remediation in United States. And then we have same rare earth mines on the acids mine drainage treatments on the USA. For AMD, this is very interesting now. I'm not sure in Asia, but in Europe, in in America, they are more on AMD now to acid mine drainage treatments. Yeah. We have iron ore mines in Brazil. I also have done iron ore mine in Malaysia. So in these projects, the TSF have reached and the river had filled with tailings, and the river had to be dredged and tailing contained on land with clean water, then returned to the river systems. And the last slide for me. So this is another interesting project for gold and copper mine. What they're going to do on the geotube dewatering, they use to construct a bund. They construct a bund using the dredge material, and then to increase the capacity of the lagoons. Yep. So that's it for me. Thank you all. So I'm sure you have a question. Maybe I can answer from the live event or maybe from YouTube. I will pass back to Pak Hadi. Pak Hadi.
Thank you, Mr. Hisam Umar, for a great presentation. I think this knowledge about tailings dewatering with geosynthetics, especially for Teknik Geotube technology. So right now we already have some question coming from our participants, and I will try to ask you the first question. It's coming from Mr. Mudiansyah. He asked about how is the estimation of the price range, cost range, maybe in dollar per ton for geotube application.
So okay, in my slide just now, I have listed three components, three factors. If you still can remember, we have three factors. We have tube cost. Number one is purely about tube cost, and then we have a polymer cost because in terms of determining a project cost, polymer cost might be vary from country to another country. Because we are not in business on polymers, so we are not specific any brands, but the price will be vary. So some might be go to $9 per kilo, some goes to $10 per kilo. And then the third factor, if you still remember just now, we have another cost, what we call capital operating cost. So each of these factors we convert into dollar per meter cube dry fix. So the range for dollar, it could be I can say it's about 10 or maybe 15 is US dollar per meter cube dry fix. So yeah. To get the exact for dollar meter cube of dry fix, you just contact to our Teknik Jakarta, because we work with a partner in Indonesia that can have a full package. So in short, to answer the question, how much the cost of the watering cost, it might be in the range 10 to $15 US dollar per meter cube dry fix.
Okay.
Padi?
Okay, thank you, Mr. Hisam. The next question, I think we have some similar question. It's coming from Mr. Francis. How many staking that the geotextile tube or geotube can be maximized that will be worked? So how much the maximum staking?
Ya, terima kasih Pak Francis ya. The highest, we can stack up to 7 layers. So I have experience stacking layers up to 6 layers. But having said 6 layers, 7 layers is not how high we can go. It also have to depend on the soil foundations. If the soil foundations is permissible, if we go to higher and higher, then we can go 6 or 7 layers, which should be no problem. But again, when we start considering to have many layers, so all the things that's involved, as you can see, if you remember my slide just now, we have a procedure. So we need to check the moisture content, we need to have a SPT test, so we need to have this kind of investigation before we determine how many stack layers that we going to do. Padi, yeah.
Okay, thank you. And maybe the next, some Mr. Francis, he just asking about where is the first time the geotube has been used in Indonesia? The first time, if you can recall.
So I have done many proposals, mainly in South Kalimantan area, in the east, then in the west. Yeah. So the first geotube that we have installed at this South Kalimantan. Yeah. Yep. South Kalimantan for the coal mine. Yeah. That is the biggest project that we have handled just now, and it still keep ongoing until today. Yep. Padi.
Okay. The next one is coming from Mr. Panghutan. The first question is the same one that you already answered. The second one is it safe to directly revegetate for the geotube for in the longer time in the future?
Is it? Oh, Padi, say again, Padi. Is it?
Yeah. Is it safe if we want to directly to revegetate, so revegetate it? I mean.
Yeah. Oh.
Yeah. For the longer time in the future on the geotube.
Yes. As you know, the geotube units emits from polypropylene and has a heavy UV protection. So at least 50% strength retention even after 5 years with a direct exposure. So after the watering, there is actually no active force on the geotube unit because the sludge, everything is already been solidified. So when the geotube be exposed, it can remain intact actually far longer than 5 years if they asking about the lifespan. I think he asking about the lifespan. So the lifespan of geotube, it can be intact far longer than 5 years. Padi, yeah.
Okay, then the next one coming from Mr. Francis again. What is the flow capacity, the biggest that the geotube can take?
So we can go to the very minimum flow rates. We can go at minimum 10 meter cubic per hour. I have done projects. Normally we pumping up to 500 to 850 meter cubic per hour, and some project in China we able to pump about 1,000 to 1,000 meter cubic per hour. Yep. What is?
Okay, we still have time. This one is coming from Mr. Ali. To determine the geotube volume, as you said in the presentation, is it more accurately to determine the volume with specific gravity or total solid system?
Yeah, we normally, thank you, Padi. Normally, we need to use SG solid to determine on geotube volume. We don't use total solid suspension. Yes, sir.
Okay.
Yes. To answer Ali, we use SG solid, sir. Yeah.
Yeah. To be noted. This one coming from Mr. Aris. What can be the expected lifespan of the geotube units?
I just answered just now on the expected lifespans. So we have a heavy UV protection, 50% strength retention after 5 years. Yeah, So, yeah, the YouTube can remain intact for longer than 5 years. Yep, Padi.
Okay, there is still coming from Mr. Hari. Can we use plate vibrator on the fabric of the geotube to enhance water coming out fast?
Oh yes. So plate vibrator. You mean plate vibrator, Pak Adi? Yeah. Plate vibrators. Have been used by some people, but it's not common. I've seen this plate vibrator being used in the YouTube. So we would prefer non-mechanical means and metal part that risk cutting the fabric surface. So wooden pedals or sticks are sometimes used. However, it's good to brush on the surface of the geotubes, or we use water jet spray onto the geotube fabric is recommended. So either we brushing, brooming, or we use the water jet spray.
Okay.
Adi?
Okay, maybe this is. There is still one from Mr. Baharudin. Is there any environmental issue from telling the waterings with geotube?
Is there any environment issues? How to prevent? I'm not sure.
Yeah.
Is there any environmental issue? Because I'm not sure what kind of environmental issue. If you talking about the influence,
definitely.
So if he talk about influence, might be TSS or BOD or COD level. Normally the reductions from before to after is more than 90% of reductions, especially on the TSS. I don't see any environmental issue as long as the installation of geotube is correct. So we keep on monitoring on the polymer dosage. If you still remember, we have to get a very good flock. We have a bigger flocks to retain solid in the bags.
Yeah, I think that's all for your session, Mr. Mohisan. Thank you for your great presentation and answering all the questions. For all attendee, untuk semua para peserta yang mungkin masih ingin bertanya, masih bisa memasukkan pertanyaan walaupun waktunya telah habis. Kami akan tetap mencoba menjawab. We will try to answer all the question that maybe some attendees want to input it after the webinar. And also, if you still want to see this webinar, you still can join with the link to join this webinar also, and then the recording will be played from the beginning of the webinar until the end. And maybe for you all, our attendee or any participant that interesting, especially from Indonesia, interesting to talk about or discuss more about regarding geosynthetics application for mining, you can send us the email from our email in geo.indo@tenkatgeo.com. Thank you for all attendees and participants that already involving in this webinar from the beginning until the end, and maybe the other of the participants join us in the middle of the webinar. And thank you too for all our superb speakers for today, for the knowledge sharing. And I hope, and we hope also, this knowledge sharing will elevate our understanding in using geosynthetics for mining application, especially in Indonesia. I deeply apologize if during this webinar there were some problems occur and make you inconvenient. Thank you, and see you in another webinar. Goodbye.
Wah, pas. Wah, banyak orang Indonesia tag saya. Dari Sulawesi lah, apa lah.
Oh, dia tag you.
Banyak ah. Ada lebih kurang 200 lebih.